Hello, hello, intermediate algebra students. We are going to do our last lesson today of Unit 1. This is 1.7, the line of best fit. Okay, open it up to a blank page. 1.7, the line of best fit. This lesson is exactly what it sounds like. We're going to be given a bunch of data points. Draw the line that best goes through most of the points or goes around. So around it. All right. And in order to draw a line of best fit, the way that we talk about it is this word called correlation. Correlation, let's see, there we go. Correlation is a relationship between two data sets. What is it? What is the relationship? Between two data sets. And they can kind of have a couple of different correlation options. So I'm going to draw just three little graphs here. One like this. Doop, doop. I'm going to stick with just the positive quadrant. So let's say I've got a data set, something like this. So in my first graph here, let's just put some data points, and mostly they are trending up. This may be what will be a good example of this, like the number of books you own versus age, maybe, or your shoe size compared to your age, because your shoe size generally increases. And this is what's called a positive correlation. It's generally going up. So for this one, as X increases, so like as age increases, Y also increases. Your shoe size also increases. As X increases, Y increases. Then you could have something that is falling down. For example, your age and the number of teeth you lost that year generally goes down as you get older. This would be a negative correlation. And this one is just the opposite. As X increases, Y decreases. As X gets higher, Y goes down. This would be a negative correlation. Whatever's happening as X goes on, whatever it is going down. Much more rare. I don't know if we're going to see this at all, but there are also graphs with no correlation. No, and they might look like all over the place. They might look something like this. And this may be like the number of pillows on your bed. Totally arbitrary. Like there's no correlation between age and the number of pillows you have. Something like that. And so this just shows no relationship. They're not correlated. They're not related. None. Now in these three examples, I can draw what is called a trend line. Or a line of best fit. And this is just a linear function that models the correlation. And generally, it's going to be like half of the points are above and half are below. No point has to be on this trend line. Half above and half, half of the points are below. Okay. We're going to take a look at a example. I'm going to show you a picture of this example. And this example is the correlation between the temperature and the time. All right, and I'm just going to show you the graph, and then we're going to kind of do a little rough sketch of it. Looks like this. Okay, so notice I've got, nope, that was too high. Was it too much? Yes. Notice the scale. So on the y-axis is where you have temperature, and on the x-axis, it's hours after sunset. Just gonna leave it right there. So this is going to go hours after sunset up to 10 hours later. And then the temperature, wherever this is going to vary from, like, this looks like 50, it's going up by 2, so 58 degrees up to 72 degrees. So it'll kind of fluctuate in there. So we're going to do a little sketch of this in our notebooks. It does not have to be perfect after sunset. So it makes sense that after the sun goes down, the temperature is also going down. So think about real quick what type of correlation this is. If all of the points are generally going down, it's going to be a negative correlation. Temp, and this is going to be hours after sunset. So they give this little like wiggle right here, which just means skip a few. Skip a few. I'm not going to start at 0 and count all the way up to 72 when there are no points between 0 and 60. That would be like a wasted graph. So this little zigzag means skip a few. So I'm going to start here at 60. And then it did 64, 68, 472. That's how the graph went. And then on the side here, it went up by ones to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it just labeled every other one. So you don't have to label every single point, but that's about where it was. And then your points. This is the part that this will kind of vary, but generally I want to start like right at almost to the 72. And I want to kind of fall down to about here and just kind of put points varying around this like that, something like that. Generally trending down. It does not have to be perfect at all, as long as it's kind of going down. So next, and go ahead and pause the video if you want more time to make that whatever your heart desires. Next, I need to draw a line here. So I need to draw a line of best fit. It has to be a straight line as best as you can. And there should be about half above and half below. I'm going to use like a Post-it to kind of be my straight edge here. And I'm going to pop this line kind of fit right there. All right, so now this trend line, I need to make an equation for the trend line. And the thing about the trend line I want you to be like aware of is when you're choosing points on this graph or on this line, choose nice ones. Choose kind of whatever point is it's like on a nice line. So I might choose right here. This looks like about the point, and just estimate, it does not have to be perfect. 9 and 60. Oops. Over 9 up 60. It looks nice on that line. And then let's choose one up here. And it doesn't have to be one of the points that you drew, but it should be one of the points on the line that you drew. And your points here can vary from mine. They don't have to be the exact same one unless you want it to be. For this, let's see. Oh, this one looks pretty lined up too. So this is the point 268. If we had graph paper too, it would be easier and clearer to see. This is also a negative correlation. They are correlated. They are trending down. Okay, I need to write an equation for this line. So generally, you can use any linear form, but I'm going to use y equals mx plus b since we've kind of been practicing with that one. So with these 2 points, I need to find first my m, my slope. So to find slope, rise over run, right? How far did I go down? How far did I go over? You can do this visually if you want to. This is going down 8 and it's going over 7, or the formula for slope, your rise over run. So I'm going to take the 2 y values, 68 minus 60, just find the difference there, over the run. If you started with 68, I'm going to start with 2 minus 9. So that's 8 over negative 7. That's my slope. Now I'm going to put that into the equation here. So y equals negative 8/7 x plus b. I still need to find b. So let's plug in a value for x and y so that we only have one variable going on. Do either one, 9 and 60 or 2 and 68, it does not matter. But what we'll do is just plug in, that's my x, that's my y. So I'm going to go 60 equals 8/7 times 9 plus b. So 60 equals negative 8 times 9 is negative 72 over 7 plus b. Add 72/7 to both sides to get to be alone. And then we get, let's see, let's pull up a calculator. 60 plus 72/7 is, oh no, 72/7. And you can just type this into a Google calculator if you want to. It's about 70.3. About, because it's many decimal points there. So I just rounded 70.28. That 8 rounded the 2 up to a 3. So your trend line will be 8/7 x plus 70.3 about. There's your trend line. So that means at 0 minutes after sunset, like at the time of sunset, the temperature was 70.3. It's about where your graph lines up. It shouldn't be exact, but it should be about. And then generally, this is the slope. So for every 7 hours, the temperature decreased by 8. The slope is really showing you how much the temperature is dropping per hour. If we were to write that just as a decimal, 8/7, it's 1.1. So every 1 hour, the temperature about goes down 1.1 degrees.